Hello, my name is Gyan Mishra. I am an IT technologist and innovation specialist with Verizon, and today I will be showcasing a SRv6 microSID data center use case study demo using a virtualized environment with Cisco XRD containers. Thank you. Hello, everyone. Hope everyone's having a great MPLS World Congress 2023. My name is Gyan Mishra. I'm an IT technologist and innovation specialist with Verizon. And today I'll be showcasing two host attachment types, VPP here at the bottom in Paris, vector packet processing host attachment, and then at the top, Linux kernel host attachment. And today I'll be showcasing how SRv6 microSID using the simple and seamless IPv6 data plane global table, providing the critical linkage between the host fabric and the data center fabric. Today as well, I'll be showcasing traffic engineering and the importance of traffic engineering within the data center and how being able to traffic engineer mice flows and threading a needle of those mice flows around the hotspots within the data center, elephant flow hotspots in the data center, as well as end-to-end traffic engineering across a core network from an ingress data center through a core to an egress data center, end-to-end traffic steering. And lastly, what I want to showcase in this demo, as well as being able to use the SRv6 microSID, a single uSID carrier with 5 SRv6 microSID waypoints nailed down, and how to strategically place those microSID waypoints. And in this demo, what we're doing is we're nailing down the hop between the leaf and spine layer, threading that needle around the hotspot using that link coloring. And in this case, we're using the link color green. So link coloring between router 40, router 66 and 64, threading that needle around the hotspot, and then as well nailing down those two nodes, and then picking one node along the SR algo green outer ring topology, and then in the green data center along that N-way ECMP, threading that needle around that hotspot, picking that leaf to spine node path to thread that needle through that egress data center. So now in this demo, what I'm planning to do is showcase 4 different scenarios. And what we're going to do is, as we go through the 4 scenarios, we're going to go hop by hop. We'll see the shift and forward happen on the waypoints, and then along the nodes that are just doing IPv6 forwarding, we'll see the flow along that path, the intent-based flow. So the VPP hosts and the Linux hosts, they're attached to the global table, and so we'll be doing an IPv4 ping to generate that intent-based flow. And when that intent-based flow is generated, we'll see that hop by hop along the path and being steered along the path. So the 4 scenarios we would have is we have VPP with an IPv4 payload. We'll have a VPP with an IPv6 payload generating a ping and create that intent-based flow. And then the third scenario is the Linux kernel will generate that ping to create that intent-based flow for the v4 payload. And then we're going to do the same Linux kernel with the v6 payload. And when we're doing the ping, we're creating that intent-based flow ping from Linux kernel from the top down to the bottom, and then bottom up to the top. So let's say router 46 for v4 payload, we would ping from router 66 down to router 46 to the VPP attachment for v4, and then we would do the same ping from router 66 to router 46 with v6. And then in the reverse direction, it's same ping from router 46 to router 66. From VPP, we would do that ping to the host attachment, and then we would do the same thing with the v6 payload. All right, so now I would like to go through it and describe the topology. through the network for the demo. So in the center here is the core network. So the core network is AS65000. It has an IS underlay. At the bottom here, data center 2, it's a BGP only data center, RFC 7938. And here on the border leaf layer and the leaf layer, each node is in its own BGPAS. The spine layer, the nodes router 42, 43, 44, 45, they're sitting in a single BGPAS. And then at the top here in data center 1, we have a single we have an IS underlay, and it's all the nodes they're sitting in a single BGPAS AS65060. So on the inner AS ties between the data center 1 and the core, so router 6061 to router 13 and 14, on router 13 and 14, we're doing a mutual IS-IS redistribution. So we're taking in all the IS-IS routes and redistributing them into the core network. And then we're taking the core locators as well as the loopbacks, and we're redistributing them all into the IS-IS domain back into data center 1, mutual redistribution. We are also running BGP on the inner AS tie between router 13 and 14 and the core and router 60 and 61. So we're doing inner AS option B, next hop and changed. And the reason for next hop and change is on the next hop, the BGP, the next hop automatically changes. So when that next hop changes, the label changes, but as well as the SRv6 service SID, so that and DT46, so that service SID changes. So that needs to be preserved. And so when by doing a next hop unchanged, the next hop doesn't change. So we see all the remote loopbacks, which we're flooding the loopbacks domain wide between the core, the data center 1 and data center 2. So now we're able to see that we see the remote loopbacks, and we have longest prefix matches for all the remote loops. So but by doing the next hop unchanged, the label doesn't change, as well as now the SID is preserved. So let's say from data center 1 going into the core, those SIDs are all advertised. The native SIDs are preserved and advertised. And then from the core, as well as the service SIDs from data center 2, propagated into the core and then propagated into data center 1, all those service SIDs are now preserved, and we see the remote loopbacks. In data center 2, on all of the hops on the inner AS ties, we're doing the same inner AS option B between router 46 and 47 up to the spine nodes, and then the spine nodes back towards router 40, 41, the border leaves. We're doing inner AS option B next hop and change. So on those 3 layers, all next hop and changed. And then from router 40, 41 to router 0 and 1, we're doing as well next hop and change inner AS option B to preserve the service SID, the VPN service SID, being advertised from the data center 2 up to the core, and then from the core advertising the native remote loops are advertised, and the service SID is maintained for the next hops for both data center 1 core back up down to the data center 2. So now what I'd like to do is I would like to describe this traffic steering that we have laid out in this topology. So we have 3 types of steering that are laid out in the topology. We have on-demand next hop with stateful PCE. So router 25 and 26 are acting. They're the route reflectors. They're also the stateful PCE and BGPLS. And that's since we're doing mutual redistribution between data center 1 and the core. So we have stateful PCE and BGPLS between the data center 1 and the core. Down to data center 2, we have stateful PCE down to data center 2, as well as we have BGPLS address, and we have that extended down to the data center 2 as well. So data center 2 gets all the topological information from BGPLS and its stateful PCE to build a on-demand next hop path towards the core. But however, because it's BGP only, there's no BGPLS state that's being advertised. So I want to just make that clear. So in the the types of steering that we have the on-demand X-top, and that's with two different algos. So algo 0 and algo 128, which is the low latency metric, and that's for all links are colored with algo with red, colored red, through the core, as well as data center 1 as well as data center 2, and then the algo. And that's algo 128. Algo 0 and algo 128, we're using the on-demand X-top with stateful PCE SR policy. And then algo 129 and 130 with locator, what we call for the FAD is latency 2 and latency 3. And so for those two, we're doing static SID list for those two. So that's the second type of steering. And then the last type of steering that we have is basically like the simple steering, and it's just only between domain 1, data center 1, and the core, and that is using the ISIS underlay steering, and that's using with RFC 9252 BGP service overlay, where we're encoding. It's kind of like a single level label stack versus an MPLS 2-level label stack, where we're taking the SRv6 service SID, and that's encoding via BGP prefix SID into the function field of the SRv6 SID. And so when the FAD ISIS advertises the flex algo definition, it's actually as well advertising the L3 VPN service SID that gets advertised. So there's no color to intent mapping for the steering. It's just all done via FlexAlgo and via the IGP, and that's just between data center 1 and the core. All right, so now we are ready for demo time. So we're going to start out with VPP, and we're going to go from VPP v4 ping, then VPP v6, and then we got Linux kernel v4 ping, and then Linux kernel v6 ping. So we'll go to VPP. Okay, so now what we have is we have two. So what I had here, I did a show SR policy, and those are all the policies that are defined on the VPP node host. So what we're doing is we're doing a so here we're setting the VPP SR policy, and in the SR policy you can see we're setting the destination address. So that is that's the USID carrier we're setting on the VPP node. So that maps to the steering policy for the v4 payload. So remember, VPP is connected to the global table. So we would be pinging, this address here. So 40::40. So that's the BSID. So we're going to do a continuous ping to create that intent-based flow across the core that's going to get steered, and then we're going to go hop by hop. So we're going to first do that one, and then after that we'll do the v6 payload. So this is the policy for v6 payload, and this is the USID carrier is identical as the first one. So it's the same USID carrier going through the ingress node 4440. Then you see node 4 is in the core, and then the egress data center 6466, and then this last entry is the NDT4 NDT6 decap that happens. And then this maps to the ping for the intent-based flow. So we're going to be pinging FC006 66:1. So we're going to be pinging the egress data center router 66 that has the Linux kernel attachment. Okay, so I've started the ping. So I've started a ping on here, see on the red dot here, connected to router 46. So what I'm going to do is we're going to go hop by hop all the way through. So right now I'm going to do a first trace. We're going to do a trace on between router 46 and router 44. So now you can see this is the full destination address that's set. So we're on the this is between the SRv6 source node, right? Markset source node. So we see router 44, 40, the core router node 4, and then 64, 66, and then the E000 is that's the decap. So NDT4, DT6, the decap that happens on the egress PE. So next we're going to look at between router 44 and router 40. So here, so that's the destination address that's set. So here we've already, since we're doing between router 44 and 40. So we've already done a shift and forward on the router 44 waypoint. So it did a shift and forward, and so now we see the next microsid hop that's which is router 40 in the path. All right, so now we're going to go do the next. So the next hop, we're going to do a trace between router 2 and router 4. So from here to here, so this link right here between router 2 and router 4. All right, so now you can, when you look at the we've already, since we've gone past router 40, node 40 has already done the shift and forward, so we don't see it in the destination address that's being set. Since we're past node 40, he's already done a shift and forward waypoint, so now we're on this between router 2 and router 4. And our next node is router 4. So we haven't gotten to it. We're actually like right before router 4. We're right on this link. So we see router 4 as our next waypoint. So now we're going to do a trace between router 4 and router 8. Okay. So now you can see here we're on a waypoint. We're doing between router 4 and router 8, but because we're on the waypoint, we actually did the shift and forward, and the destination address is set. So router 4 has been shifted, the node, since we're on that node. So our next waypoint node is router 64. So that's within the egress data center. So we're going to do another trace just between router 8 and router 11 just to see the flow. So we see the flow along the path to prove that we're using the entire green path. Okay, so now we're on, now we can look at that, the destination address set. So we see the flow and we see the destination address set, and we see the next waypoint node is router 64. So now we're going to do a trace between router 61 and 64. Okay. So since we're on the waypoint node, we've already done a shift and forward, and we see the destination address, and we see the next node, next waypoint is set to router 61. So now we're going to do our last final hop, a trace between router 64 and router 66. All right, so this is the very last hop. So here you can see the last hop being set. So now we have the final. So we're doing it between node 64 and 66. So the shift and forward has happened, and so now all we see is basically the final endpoint node 66. All right, so now what we're going to do is we're going to do the same trace, but now we're going to do it with the v6 payload. So now we're generating the intent-based flow from VPP, and what we're gonna start on that first hop. So between router 46 and router 44. So we see the full destination address here being set. And you see that v6 payload, see that? See, that's the v6 payload before v4. So that's what we're pinging, our source address to the destination address. That's the payload, and this is the destination address that's being set. So this is the uSID carrier. So you see the entire path there, router 44, 44 is the core node, and then 44, 64, and then 66 egress data center, and then that E000 NDT4, NDT6 decap. So the next hop we're going to do is between router 44 and 40. So now we see since we're on the waypoint, we're doing between router 44 and 40, and 44 is a waypoint. So we saw the shift and forward happen. So we see the destination address set. So our next USID waypoint is router 40. So our next hop we're going to do is between router 2 and router 4. So between router 2 and router 4, we see the next waypoint is router 4, and we see the shift and forward happened for router 40. So router 40 was in the destination address on the last trace. You can see that here, router 40, right there for router 40, right? But now in this trace, we've already gone past that node. We've done the shift and forward on router 40, and now we're on this link. So our next node, all we see is router 4 is the next node in the path. So now we're going to do a trace between router 4 and router 8 is our next hop. Okay. So now we're on the waypoint router 40, and so we've done the shift and forward. Process did the shift and forward, and so now we see the next waypoint is the egress data center. So data center 1, router 64 and 66. So now we're going to do another trace on 8 and 11, between 8 and 11, just to make sure we see the flow there. And we did the trace, and we see it. So let's see right here. So we see the next two waypoint nodes, but we see the flow and we see the node 2 waypoint nodes being 64 and 66. So now we're going to do a trace between router 61 and 64. So now we're in that data center 1. So we see the flow, and we still see the next waypoint is 64 and 66. So now we're going to get on that last final link. So this is the link between this. This is the final leg between the spine node 64 and the leaf 66. And now you see the shift and forward happen as we were on the waypoint node, going between router 64 and 66. So um, we saw the shift and forward happen. We don't see the node 64 in the destination address anymore. And we see the final destination 66. So that concludes the VPP trace. So we've done VPP to Linux kernel endpoint off of router 6, so router 46 to router 66 v4 payload, and then we did v6 payload. So now we're going to go in the reverse direction. We're going to go from a Linux kernel host endpoint steering across the core down to the VPP node. So we're going to get on the Linux kernel node. So before we do the ping, we're going to do IP route. So right now, so on the Linux kernel, he has the steering path, so the uSID carrier set. So just like we had the policy on VPP, this is within the Linux kernel. We have the destination address, which is the uSID carrier. We have it set. So we see that 64, 61, and then the core node 54, and then 44, 46, and then the NDT4, DT6 decap on the egress side. So now we're going to start a continuous ping. So now we're going in the other direction. So we're going from, we're in data center 1, and we're going to create that intent-based flow. We're going to ping from the Linux kernel. We're going to ping all the way through that ping path, and then we're going to be pinging router 46, which the VPP node is attached. So now the first hop we're going to look at, we're going to see the destination address being set. We're going to look at the path between router 66, 64. So here we see the destination address set. So that's the full uSID carrier. We see 64, 61. We see the router 4 in the core, and then we see the egress data center 44, 46, and then the NDT4, DT6 decap. So the next hop we're going to do a trace on is between router 64 and 61. So here we saw the shift and forward happened. So now we don't see the node 64 because we're going outbound between 64 and 61, and so we see that our next uSID waypoint is router 61. So our next capture point is going to be between router 11 and router 8. So between router 8 and router 11, so we've gone past that node 61. So node 61 already did its it was a waypoint, so did its shift and forward. So 61 has been shifted out. So we had that in the previous trace. The 61 was in the uSID carrier in the destination address being set. So now we see router 44, router 4 is our next waypoint that we're going to. And this last trace was between router 8 and router 11. So now we're going to go between router 8 and router 4. So this link right here between router 8 to router 4. All right, and so we still see this. We see the flow, and then we also see the destination address set. So our next waypoint is router 4. So now we're going to go here. Now our capture points between router 4 and router 2. So since we're sitting on the waypoint, router 4 has already done the shift and forward, and he set the destination address. So now our next destination is the egress data center, 44 and 46, the spine and leaf. So now we're going to do a capture. So this will be a little interesting here. So in this demo, we only have a single flow. So IPv so since SRv6 microsid, as I mentioned earlier in the demo talk, that it uses with its simplicity, it uses the global table and uses the IPv6 data plane, and with that it uses RFC6437 IPv6 flow label for its uniform stateless load balancing. So, but because we have one flow, the ECMP path, we're only hashing to a single path. So when we went from VPP at the bottom up to the Linux kernel node at the top, we had hashed from router 40, we had hashed to router 44. But now going the other direction, we're going to see that we end up hashing from router 41 to 40 instead of this. So in this direction, we went 44 to 40 because that was an ECMP hash, and that's because that router 40 is not nailed down in the USID carrier hop. So any hop that is not a USID carrier hop, it's just doing IPv6 forwarding, and on those hops, it's an ECMP stateless load balancing path using the flow label, IPv6 flow label. So now what you will see is we're going to see the flow. It's going to be on router 41 to 44. So let's look at that right now. Yep, and there we see it. We see the flow. So it actually hashed to 41 to 44. So this path right here between router 41 and 44. So now we're on our very last hop. So this is between router 44 and 46. So we've already done the shift and forward on router 44. So now we see the destination address. We have the final waypoint, node 46. So we've completed. So now we have completed successfully the Linux kernel to VPP steering with v4 payload, and now we have the final trace, which is using the v6 payload. So Linux kernel with v6 payload. So now we've started a continuous ping, and we're pinging, and now we should see this path. We should see the v6 payload along the path, and we'll go trace hop by hop. So now we see here we see the full destination address set. So we see node 6461, and then we see the core router 44, and then 4446, and then the NDT 426. So that looks good. We see the flow. So now the next node we're going to do 64 to 61. So node 64 is one of the waypoints, so it did the shift and forward. So now we see the new destination address set, and we see, there we go. We see the next node is 61 waypoint. So now we're going to do capture between router 11 and router 8 up here. So now on router 40, now router 41, router 61, we had already done the shift and forward because now we're on router 11. So we see the next waypoint, which is router 4. So we see so we're doing a capture on this link here. And we've already gone past this node, router 61. So it was a waypoint in the uSID carrier. It did a shift and forward. So now our next waypoint is our router 44. And we see the flow here and we see the destination address. So there it is. So now we're going to go to our next path. We're going to do our capture point between router 4 and router 8. All right, so we see the flow, we see the destination address set, we see our next waypoint is router 4. So now we're here. Now we're going to do a capture right here between router 4 and router 2. So here we see the since we're on the waypoint on router 4, the shift and forward has already happened. So now we're on the we have our next waypoint is the egress data center, the last two nodes, the spine 44 and then leaf 46. All right, so now we're going to do a capture. So just as we mentioned when we were in the previous one, when we're going from Linux kernel to VPP, that the hash, we're going to be hashing again to this path, the router 41 to router 44, instead of the 40 to 44 that was done in the other direction. So we're going to take a look at this capture here from 41 to 44 for that IPv6 flow label hashing. And there it is. We see the flow there. And we see the destination address set. The next waypoint is router 44. So we are on our very last hop, 44 to 46. So let's go take a look at that guy, very last hop. And there we go. We see it there. We see the shift and forward happened on, we're on between the node 44 and 46. The uSID carrier, uSID hop for 44 is shifted. And so we see the final destination uSID hop left node 46. And that completes completes the entire traffic engineering with Linux kernel from V4. So we did V4, and then now we finally can finish the V6 flow and trace end-to-end from Linux kernel host all the way end-to-end through the core to the egress to the data center to node 46 to the VPP endpoint. So this concludes the demo for SRv6 microSID data center use case study. I hope everyone enjoyed this session. Thank you, and hope everyone has a wonderful remaining MPLS World Congress 2023. Thank you very much.